G'day friends, I'm James, and this is part 2 of videos on linear programming. And this is the second type of problem that often appears on national exams about this topic of linear programming, and it's actually really quite complicated. It's a lot to actually get through for students. Okay, so here's a typical exam question. A farm is to be planted with corn and with maize, with the following constraints, and the constraints are given like a little table. The days of labor per hectare. Okay, for wheat, it requires 2 days of labor for 1 hectare of planting. For maize, 1 day of labor, and we can do at most 10 days of labor. The cost for labor per hectare in Tanzanian shillings is 700 shillings per hectare for wheat, 600 for maize, and we have at most 4,200 to spend. The cost of fertilizer per hectare for wheat is 300 shillings, for maize is 400 shillings per hectare, and we have a maximum of 240 shillings to spend. Whoa, there's a lot there. The question comes in 2 parts. Part 1, find the maximum number of hectares we could possibly plant. And step 2, the wheat profit is actually 800 shillings per hectare. So I plant 1 hectare, I get 800 shillings profit. Maize, 600 shillings profit per hectare. I want to maximize my profit. Please make all this happen. Oh, whoa, there's so much here, Okay, so here's how my brain works my way through this. It takes a very long time. It's a very complicated problem. We just have to do our best with it. First of all, I wrote W for wheat, M for maize. So one of the constraints we have now for each hectare, okay, actually, let's do this. Does W equal the number of hectares of wheat? Actually, that's a very American thing, is to write that hashtag for numbers. M would be the number of hectares of maize. So I'll let those W and M stand for the number of hectares. And the first one is wheat takes 2 days of labor per hectare, maize takes 1 day of labor per hectare, and the combination of this I can have at most 10 days of labor. So the first constraint says that, if I have W hectares of labor, it'll take 2 W days of labor, 2 Ws. And for maize, I have for each hectare of maize, I have 1 day of labor plus 1 times M. And I want this to be at most 10. At most 10. All right, so the first constraint expressed mathematically is that 2 W's plus 1 M is less than or equal to 10. All right, next constraint. The labor cost per hectare. So this is all per hectare, so that's good. 700 shillings for wheat, 700 shillings per each wheat hectare I've got, plus 600 shillings for each maize hectare I have, and I want that total cost, 700 for each of W hectares, plus 600 for each of M hectares. I want that total to be less than 4,200. Whoa, my pen's getting a bit weak. Do I have a better pen? Let's see. Finally, the cost of fertilizer. Well, 1 hectare of wheat costs 300 shillings, so W hectares will cost 300 times W. 300, oh yes, better marker, 300 W. 1 hectare of maize costs 400 shillings of fertilizer cost, so M hectares will cost 400 times M. 400 times M. So that's the total cost of fertilizer, and I want it to be less than or equal to 2,400. All right, this is crazy. And now I want to do 2 things. Part 1, as opposed to part 2, careful. What's the maximum number of hectares that we could possibly plant here given these constraints? Well, we're going to have W hectares of wheat and M hectares of maize. So we want to maximize in the first part. The total number of hectares would be W hectares plus M hectares. We have to maximize W plus M in part 1. In part 2, however, we'll do something different. We want to maximize the profit. And we get 800 shillings of profit for each wheat hectare, and we get 600 shillings of profit for each maize hectare. So in part 2, we want to maximize, 1 hectare of wheat, 800 shillings, so W hectares of wheat gives me a profit of 800 Ws, plus 1 hectare of maize gives me 600 shillings of profit, so M hectares of maize gives me 600 M shillings of profit. Oh my goodness, so it took me all that time just to translate all that into mathematics. So here's what the math problem is. If I've got W is the number of hectares of wheat I've got, M is the number of hectares of maize I've got, here are the constraints, Please find the maximum for that as part 1. Please find the maximum value of that as part 2. All right, I guess I've filled up my entire screen. I'm going to have to erase some stuff here, so hopefully I can erase the question now, and that actually makes sense for us. So let's see if we can make sense of this equation. All right. So first of all, I guess it seems natural to do this pictorially, like we did in part 1. So let me do 2 number lines. 1 number line for, I know, wheat, and 1 number line for maize. Okay, great. And we'll put them as coordinate axes. First of all, 2w plus m is less than or equal to 10. Less than or equal to. Oh. If you remember, I don't mind, where's my ruler? Here's my ruler, over here. Sorry, got my ruler. 2w plus m equals 10 will be some line, and less than or equal to 10 will be all the stuff below it, smaller. Aha! 700w plus 600m would be equals 4200 would be some line, and less than or equal to 4200 would be all the points below it. Do you remember that sliding idea of sliding lines? And finally, this is actually 300w plus 400m equals 2400 would be another line, and less than or equal to 2400 would be all the lines below it. So I can see this is actually describing a region of the graph. This is describing a region of the graph. This is describing a region of the graph. So let's get all 3 regions. Oh, also, you can't have negative maize and you can't have negative wheat. So actually, we're all doing this in this quadrant right here of m being positive and w being positive. So everything's happening right in here. Okay, all right. So my brain says, let's look at, first of all, this being a line equals 10. So let's see, when m is 0, 2w equals 10, so w will be 5. W will be 5 when m is 0, so 5 and m is 0. And when w is 0, m would be 10, bingo, 10. So there's 2 points on that line. Beautiful. There is this first line. Then let me call this line A. There is line A. Beautiful. And then when I go less than or equal to 10, it'll be this line, all this region over here. Got it. Great. Let's do this line. I'll call it line B. Oh, 700W, 600Ms, 4200. Let's divide everything by 100. So it's really the same as 7Ws, 6Ms, equals 40, is less than or equal to 42. That's much easier. Let's do that instead. It's equivalent, it's fine. If it's equals 42, I would have this line. When W is 0, M would be 7. M would be 7. When M is 0, W would be 7 times 6 is 42. So this will be 6. So line B is this line. That's line B. Great. And then less than or equal to 42 would be that line and all the smaller values. So actually now I see I'm like in this sort of funny region here and also positive. Okay, but we've got a third line. Oh, 300, 400, 2400. Let's divide everything by 100. An equivalent line would be this one. 3 W's, 4 M's, less than or equal to 24. C. Let's make this line C. Line C. 3 W's, 4 M's is 24. If M is 0, W would have to be 3 times 8 is 24. Ooh, 8, okay? And if W is 0, 4 times 6 is 24. W is 6, lower, 6. So this will be the line through here, but now I'm nervous. Because if I connect these 2 points, do I go through that intersection? Am I above that intersection? Am I below that intersection? Oh, I'm nervous about that intersection right there. Ooh. Okay. How am I going to think my way through this? Well, first of all, okay. Going from 6 to 7 here gave me this line. If I bring this down low to 6, that definitely makes it lower. It's below the intersection point. And actually, maybe I could argue, if I went out a little bit further, it makes it a little bit lower still. Maybe I'm just under. Whoa, that is nerve-wracking. There's part C. I have a feeling I'm under. So when I go less than or equal to 24, I'll be under that line even more so, less than or equal to 24. So I think the feasible region is this. All All right, so if we're nervous about that, we have to like really do some mathematics there. Find the coordinates of that, find the coordinates of that, and check that the coordinates of this intersection point is really lower than that intersection point. And actually, I'll save that mathematics. You should really check that. This makes this a very long, complicated question. Anyhow, but right now, given part 1 of this video, we know the maximum value of any of these, any linear equation like this, it's going to be somewhere at a corner of this region. Whoa, 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 whoa. Great. So all we have to do is work out the coordinates of this point, coordinates of this point, coordinates of this point, and that's the hard one, the coordinates of this point. And actually, I bet that will give the maximum this will tell us which one gives us the maximum. And you can probably guess, for this to be an exam question, it's probably going to be that point every time. But we don't technically know that yet. We should check that. We should actually make sure the math says that. So, whoa, let's do that. Okay, let's do that. All right, what are the coordinates of these points? I'll do the easy one first. 0, 0. Okay, that gives me areas of W is 0, M is 0, gives me 0 hectares of property. I bet that's not the maximum. This one here has coordinates 0, 6. That gives me 6 hectares of property. That's better. This one, it gives me is coordinates 5, 0. 5 and 0, 5 hectares of property. Not as good as that one. Let's find that one. That's the intersection point of this line and this line. So this line's what? A and C. A and C. All right, so we've got 2W plus M equals 10 for the actual line, and 3Ws plus 4Ms equals 24 for the line of C. All right. Ooh, how can I make these equations friendlier? 1M and 4Ms. Let me quadruple the first one. Quadruple. 8Ms plus 4Ms equals 40. Keep this one the same. 3Ws plus 4Ms equals 24. Now if I subtract these two equations, 8Ws take away 3Ws is 5Ws. 4Ms take away 4Ms is no Ms equals 40 take away 24 is 24. So there's 16, sorry, 16. So W must be 16 fifths. What's that? That's 32 tenths, that's 3.2. Okay, 2 W's is 32 fifths plus M equals 50 fifths. So that must mean M is 32 fifths plus 18 fifths. 18 fifths is 50 fifths, is 10. That's it. So the coordinates at this point, you have to do so much work for these questions. These questions are so hard. This is the point with coordinates 16 fifths, 18 fifths. 16 fifths, 18 fifths. All right, there we go, bingo. And if you prefer decimals, what did I say? That's going to be what, 3.2, and this is what, 36 tenths, 3.6. So that's easier, great. All right, so which of these maximizes the number of hectares you've got? W plus M. W plus M is 6. W plus M is 0. W plus M is 5. W plus M is 6.8. Biggest number. Bingo. Answer, W equals 3.2, M equals 3.6. That maximizes the total number of hectares you've got. Beautiful. I wonder if it also maximizes the profit you'll get. We'll have to work this out. Okay, maximize the profit you get? Let's do it. Okay. What's the profit you get here for this point? 0 and 6. That'll be 30. Okay, so here the profit equals W times 0 plus 600 times 6 is 3,600. Here the profit you get with no W's and no M's is profit is 0. Not very good. Here you get the profit is 5 of these, 4,000 and none of those, so that's 4,000. And I bet the answer to the profit is going to be this one. It's going to give us the biggest, but we need to actually technically check. 800 times W. What was W? Oh, W was 3.2. 800 times 3.2 plus 600 times 3.6. Do you know what? I really don't like these questions. These are just so awkward. These are so awkward. Can we beat 4,000? That's all we need to know. Okay, what is it? 800 times 3 is 2,400. Plus 800 times 0.2. Oh, 0.2. That's 160, I believe. Plus 600 times 3, 1,800. Plus something else. The reason I'm not going to bother working it out, because 2,400 and 1,800 is already bigger than that one. This one, I don't even have to work it out. It's bigger. It's bigger. So I know the maximum without even knowing the number. The question didn't ask me the number. Is actually, again, with W being 3.2 and M being 3.6. And you know, the psychology of these exams is that you bet the tricky point is always going to be the one that answers the actual question. So if you're in a hurry and you had to just make a guess the tricky point, it's probably going to be right. Oh, golly gee, there's so much work in these questions, and there's so much students have to understand. There's a lot here. Teaching the theory of linear programming is actually really, really hard. There's so much maths involved in this one. And hopefully these little videos can help show you what the maths actually is behind the scenes here. It's really quite complex and involved. But with part 1 and part 2 together, I think we've covered all the typical things that the curriculum expects. So hopefully this has been helpful. All right, thanks so much, and I'll see you next time.